Hello everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you a little bit about CCNA, CCNP, CCIE related technologies. Our topic today is what is the address structure of ISIS? How is it different from an IP address? First, in ISIS, there are two main address types involved. One is the address of the NSAP. One is the net address. NSAP address. It's called Network Service Access Point. Network Service Access Point. It is defined in OSI. OSI defines the NSAP address. It is mainly used to locate resources. So what is the location of the resource used for? Let's go into a little bit more detail. It is equivalent to the OSI Network Layer Protocol. It is the CCNP address in the OSI Network Layer Protocol. That's the address of the NSAP. It does not strictly represent an address concept. CCNP address in the OSI Network Layer Protocol. We talked about that earlier. This is called a connectionless protocol. Similar to an IP address. IP protocols have IP addresses. CCNP also has the concept of addresses. It's just when OSI is defined. Call it the address of the NSAP. The constituent structure of the NSAP address. It is divided into IDP and DSP. First, let's talk about IDP. IDP is divided into AFI and IDI. AFI stands for Organization Identifier. It's like an institution. The ISIS protocol must be used. You need to have an NSAP address. In the early days, you need to purchase the NSAP address from ISO. And then I'll give you a section. Take for example the United States. I used AFI starting with 45. So we're going to assign 45. It belongs to the United States government. AFI stands for Organization Identifier. Which organization it is? IDI mainly represents a number of subordinate institutions. For example, how do you use it in the US government? There are militarized departments involved. Demilitarized sector. And other departments. It's not just the government that's on the hook. And then there are the corresponding components. IDI is again divided from rows. The IDI, for example, 0001 is for the military sector. 0002 is for the demilitarized sector. 0003 to other departments. This is how it differentiates. The DSP is made up of three parts. High-order DSP is more detailed. Like in the military sector. It's for the Army. It's used by the Air Force. It's a hierarchical concept. If the demilitarized sector. It's for the government. Or for the common people. This is a high-order DSP. The following system ID. It is equivalent to RID in OSPF. Uniquely identifies a router in an area. SEL is called Network Identity Service. You can also call it a Network Services Discriminator. SEL mainly represents a certain service. So an NSAP. It's not 0. Like 01, 02, 03, 04. Yeah. It represents some of the corresponding services. SEL is equivalent to IP packets. Protocol in the IP header. Protocol field. SEL is used to identify the upper layer protocol type. What protocol does the identity layer use? This is the address of the NSAP. It looks simple enough. The first three parts AFI IDI. The high-order DSP is the region of representation. It's just that the extent of the region is divided from the largest to the smallest. This is actually representing a specific region. The following system ID indicates the router in the area. SEL indicates the service of the router. What is the net address next? Net addresses are a special class of NSAP addresses. Why is it special? 0 SEL is fine. This IS net address ISIS. Just using the net address. It's called the network entity title. Some are also called network entity identifiers. ISIS configured on the router. You only need to consider the net address. Nothing else needs to be considered. So SEL, that's what we were talking about. It is equivalent to the protocol field in an IP packet. The absence of a protocol field represents a specific node. Net address we also do a detailed introduction. First of all, it is divided into the area ID section. It is between 1 and 13 bytes in size. The system ID is 6 bytes. And SEL is 1 byte. So net address. The maximum is 20 bytes. The minimum is 1 byte for the zone ID. The system ID of the next 6 bytes. And 1 byte SEL. That adds up to 8 bytes. So the whole net address range. That's between 8 bytes and 20 bytes. How do we match the net address specifically? Let's say we write a net address 49.0001.000.00000.0002.00. So this is the area ID right here. The middle 6 bytes are the system ID. The next byte is SEL. It has to be 0. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message. Or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.